Standard deviation is the natural scale of a distribution. It quantifies how far a typical value sits from the center, not in abstract units, but in the same units as the original data. Standard deviation inherits its structure from variance. Taking the square root restores the original unit. The mathematical structure underneath remains unchanged. Shifting the data does not affect the spread. Scaling does, by exactly the same factor. Standard deviation is sensitive to scale, not to location. When two independent quantities are combined, their variances add. Their standard deviations do not. The combined spread is smaller than the sum of the individual spreads. Two distributions can have exactly the same standard deviation and look entirely different. Standard deviation captures the width, not the shape, not the asymmetry, not the tail behavior. Standard deviation requires the second moment to be finite. For distributions with very heavy tails, this condition fails. When it exists, standard deviation measures spread, not risk.